Hello, this is Aaron Holmberg at Corvallis Middle School in Corvallis, Montana. And today I'm going to show how to do related problem sets. These related problem sets, this is very important for students to be able to think really flexibly and know that if they know basic math facts, they can make this sort of math easier by kind of looking at what's underneath it and simplifying it as they go. So this is just a homework assignment I've given in class, and I'm going to do a few of these together. The first thing I've been teaching students is that when you have a set of problems like this, is of course you're going to look at what basic fact is sitting in there. So 3 times 8 is 24. And in class that means we just start saying this is 24 all the way down if nothing else is happening to these factors. If it's a 3 and an 8 all the way down, then it's going to be 24 all the way down. So in number 2 here, it's 6 times 8, and I put that down. This one here, what times 8 is 56, it's going to be a 7 all the way down. And so that's an important step if you're helping your student at home, is just start by recognizing these math facts. And you might do that all the way through the entire assignment before you begin to work with the other parts of it. So now I'm going to switch colors a little bit to emphasize this. Students don't have to do it in color, but you're always welcome to, because sometimes it helps. Okay, so what I do in class is I teach that we're trying to balance the two sides here of the equals. And they're going to balance out, and you want to balance by factors of 10. The zeros are a factor of 10. So that's 3 times 10, and you want to make sure that the equation is balancing in a sense. So if we make math easy, if we see that there's a 0 here and we take the 0 off for a second, and I know that's not a very precise term, you're actually factoring the 10 away is what you're doing. You're dividing by 10 to remove the 0. But we just say take it off. Then you know that you need it on this side, and you balance it by putting that little dot in there. What can be really important to students is to talk like this, and maybe even ask them to talk this way. 3 eighths is 24. 8 threes is 24. 24 divided by 8 is 3. 24 divided by 3 is 8. That's really important that students can see all those relationships going on in there, because when they get to this next one here, they want to say that 30 eighths is 240, or 8 thirties is 240, and that helps reinforce the idea of this power of 10 sitting in there. On this last one again, we're going to say here's the equals, and we're going to balance the number of 10s on this side with the number of 10s on this side. So I'm going to cross those out. I've got 3 of them, and that means that I would need to have 3 10s on the other side to balance out like that. So that's kind of how the work looks. I'll show 2 and 3 real fast here for you, and I won't really speak much as I do it. Oh, in this case, I'm sorry. In this case, we have the equals here, and we're going to cross off 1 0 here. We're going to balance on the other side, and we say, well, we still have another 0 on this side, so in order for it to balance both sides, this has to be a 0. And we kind of count it by putting a little dot in there. I guess I do have to talk. This one here, you don't have any zeros on this side, and you have 1, 2 on this side, so you've got to bring those back over here like this. 6 800s is 4800. Okay, number 3. That's true. So on this side of it, we've got 2 zeros, and since there's no other zeros on this side, we need to put 2 zeros right there. On this one, we have some zeros that can balance, so we cross 2 off here and balance them with over here. In class, we talked about which ones does it matter that you cross off to balance. It doesn't matter. You can cross them off anywhere as long as you're keeping track of the 1 or 2 that are necessary to balance the equation. I'd like to quickly show then why does this work? What's going on here? And I'm going to show you with this problem right here. I'm going to zoom out just a little bit because I want to show a little bit deeper of the concept of balancing it. If I have 30 times 800 like this, and I'm trying to figure out what that's going to equal, then I need to remember this. 30 is 3 times 10, and I'm multiplying here by 800, which is 8 times 10 is 80, times 10 is 800, and that's going to equal, on this side, I can see here I've got 24,000. So I really have to zoom out here to show both sides of this. I hope this still works for you. That would mean that I have 24 times 10, 100, 1,000. 10, 100, 1,000. And you can see it. That's 100, and that's 1,000. So there's all those 10s. Now, if I'm talking about this balancing issue, well, you can see it. If I were to take a 10 from this side, oops, I have 100 right there, that's wrong. If I were to take a 10 from this side, I would have to take a 10 from this side for things to equal one another. If I took a 10 from this side, I'd have to take a 10 from this side for things to equal one another. So 3 times 8 is the 24, right? 3 and the 8 and the 24 are just sitting right there. And right now you'd see, just based on the number of things I've crossed off, I have a 10 and I have a 10 sitting here. And so if I were to cross off that final 10, what you see, all that's left over is simply the 3, the 8, and the 24, which is that basic math fact that they're studying. So this idea of factoring away those 10s and those balancing of them, that's what's really behind this trick of crossing things off.